Okay, buenas tardes, good afternoon. My name is John Mitchell. Today, I hope to demystify blockchain and Web 3.0. So a little bit about my background. I have almost 15 years in academia and over 15 years in industry. Currently an international visiting professor at Tec de Monterrey in the Guadalajara campus. So today, so the internet connected world, which includes, everyone on this call, we are in a crossroads when it comes to the internet. So in the 90s, we had Web 1.0, which was read-only medium with posts, mostly from large companies. Today's Web 2.0, is dominated by social media with rich user-generated content provided through centralized platforms. And that's a key point, is that it is centralized platforms. Now, centralized platforms such as YouTube, Google, and Facebook, Instagram, Twitter, we know all of them. Those are consolidated by a very small number of companies. They control almost all the content on the World Wide Web. So what's next? So many people believe it's time for a decentralized web. Web 3.0 and blockchain, that's what we will cover in this course. And you could really decide for yourself. We will not cover the metaverse. That will be really for another day. And that's a whole, obviously, separate topic. So the blockchain is an internet-based distributed ledger technology. And we're going to look at what a distributed ledger is. So there's 4 types of blockchains. We're going to only be talking about the public blockchains. And this is where many of the apps, such as Bitcoin, are on. They're on the public blockchains. So Web 1.0, we had centralized content, and it was really pushed to consumers, right? It was not interactive. Users were passive and web pages were static. The content was provided by corporations who helped influence fashion and other norms. So corporations were the influencers during Web 1.0, even though they weren't called that at the time. That term, became popular much later. And then here's what some of that content looked like, right? You have these women here exercising, and words so many words on here you can't read. So obviously very kind of immature, I would say, in the production of that media. Okay, now Web 2.0 emphasizes user-generated content, ease of use, participative culture, interoperability, and the influence are really athletes, entertainers, and a mixture of really of different fields. I would say that TikTok is actually at the forefront of what I'd call infotainment. Okay, so for example, this woman is 24 years old. Her name is she goes by Miss Excel. She makes, almost $10,000 a month via social media, okay, teaching people how to use Excel, okay? But the amazing thing about that is Excel has been around for 40 years, older than most of the vast majority of our students. And it really hasn't changed that much. So what has changed, though, is the delivery of the training. That part has changed. And she just does, obviously, a very wonderful job of making it entertaining and quick and brief and small nuggets of information, which seems, the public has an appetite today for that type of training. So with Web 3.0, it's a new iteration of the World Wide Web based on blockchain technology, and it'll incorporate things like decentralized and token web-based economies, and we'll talk about that. So it's interesting really to observe how the internet adoption has increased over time. You see Web 1.0, very static. It went up pretty significantly with Web 2.0 and is really continuing to climb with Web 3.0. If we look at adoption rates, we see a big spike in the number of users on the World Wide Web with 2.0. Now, and remember this is the amazing statistic, right? It's a number, big deal, right? But there's 7 billion people in the world. About a third of them alone use Facebook. And not just use it, spend considerable amount of time on there. So now back to blockchain. So blockchain is a distributed, encrypted ledger, which is shared amongst nodes of a computer network, and it's internet-based. The encryption part is always, of course, that's the key part, right? Anyone could have a database, but if it's not safe, it's not much of a database, right? So how does blockchain secure and encrypt its content? And so allow me to introduce encryption. So the most widely used encryption technique in the world today is still RSA encryption. The security of RSA relies on the practical difficulty of factoring the product of two large prime numbers, called the factoring product. It was invented by, you guys hopefully will like to hear this, by faculty. 3 faculty members noted here from MIT. They spent over a year trying to invent the algorithm. And then finally, as the urban legend goes, after several bottles of wine, they were successful in creating the RSA algorithm. Now, here's the amazing thing too, is that was in 1977, before most of our students were born, and the algorithm is still widely used today. When you think about all the hackers in the world are trying to crack this thing, and it has definitely stood the test of time. So let's take a look at what it does. So RSA is let me move my screen here, is asymptomatic encryption, okay? The public key locks the message, the private key unlocks the message, much like a key to a mailbox. So the public key is mathematically linked to the private key, and it's generated after you have the private key. So by knowing both the public and private keys, messages are encrypted with the public key and decrypted with the private key. So entities in the network then, they generate their own unique private pair of private and public keys. The public keys, again, is a derivative of the private key, so they're mathematically linked, right? And so in order for B in this example, in order for B to send a secure message to A must first share his or her public key with them. In this case, then the encrypted message or hash value is the new value of the data after it has been sent through the mathematical function of the public key. So here we see the message, I'm looking forward to summer. Sorry, I'm a teacher. I'm looking forward to summer is encrypted into a hash, okay? You don't know what this means when you see it out in the public, okay? So what's the requirements of a hash? A hash accepts a message or an input of any length and creates an output of a fixed length. By the way, there's 3 people in the waiting room I see. So if someone wants to let them in, that would probably be a good idea. I don't think I can let them in. Okay, so the requirements of a hash is accept a message input of any length and create an output of a fixed length, which is called a digest. Each digest is unique for any given input. And being unique, they lots of own unique terms in cryptography. They call it a collision. So there's no collisions meet the requirements of the hash. There is a chat here. Should I be looking at the chat? Okay, I'm not going to look at that one right now. So maybe someone else can raise their hand. Okay, so again here, the encrypted message is then sent through the mathematical function of the private key, and the original message is then recreated. So let's take a closer look at that, okay? So we convert the message, I am looking forward to summer, into ASCII, okay? The American Standard Coding something or other, I forget what that stands for, but it's the equivalent numbers for letters so that computers can understand them. The public key converts it into what they call cybertext. Okay, we see cybertext here. Now the new cybertext is then run through the private key, and then the original message is recreated. Now, this RSA algorithm is used for the creation and encryption of blockchain wallets. So that's how people are able to send money back and forth from their wallets. Again, another kind of crypto or Bitcoin terminology. A wallet is really basically, think of it as your bank account. So the public key is to receive crypto payments. The private key is to make payments. So I realize that the math behind the RSA keys is complicated, and I glossed over it. But for those interested in a deeper dive, the URL displayed provides a good explanation of the mathematical theory and a lot of the kind of gory detail. I must warn you, I was a computer science major and a math minor, and I found it to be pretty challenging, having been out of college for many years. But it's quite fascinating if you think about what these mathematicians and scientists were able to do. Okay, so besides the payments, though, blockchain uses SHA-256. So SHA-256 stands for the secure hashing algorithms. It's a family of algorithms developed mostly by the National Security Agency, which is a department within the United States Department of Defense. Right now, the associated number, the 256, that represents the number of output bits from the digest. Remember, any length input can come in, it's converted to a fixed output. For the SHA-256, it's converted to 256 bits. Okay. Now, if you're so again, we could take something like a riddle or a poem or a book, right? Run it through the SHA-256 hash function, and it would come out with a digest of 256 bits. Okay. Now, you may not at first glance think that's a lot, but it's actually quite a bit. Here, if I take I am looking forward to summer, this is it in hexadecimal. It creates a number that looks something about this size, okay? So the point is 256 bits can represent a number that's 2 raised to the power of 256. That number, the number of possible outcomes, is greater, they say. I don't know how they would prove this, but they claim that it's greater than the number of atoms in the perceivable universe. Okay, so lots of heavy math and theory there. So what I like to do is kind of break that up for our students here with maybe play a little joke. And there's a little video clip in the notes here. Here's a note where it's a 30-second clip from the movie Dumb and Dumber with Jim Carrey, something you may want to show in class to break things up. So in the clip, Jim Carrey asks a woman, he says, "What are my chances of you going out with me?" And she looks at him and shakes her head. She's an attractive woman. I saw the movie. She says, "Not good." Jim Carrey replies, he said, "Like 1 in 100?" She says, "More like 1 in a million." And he says, "So you're telling me I do have a chance." So I thought that was a hilarious line there. Okay, so a transaction, this is an example of a blockchain that uses a term, I'll introduce, proof of work, okay? And we'll cover that next. What is proof of work? But here's a typical, what a blockchain transaction looks like. So a transaction is requested and authenticated. A block representing that transaction is created. So a block is just a block of a chunk of data, and I'll show you the format of that coming up. The block is then sent to every node. These are these different participants, or miners they're called, in the blockchain. Those nodes are then validated. So if I'm saying, hey, I'm going to send Paul $100, they're going to look at that and make sure my address is correct, make sure I have $100 or 100 Bitcoins, and make sure that Paul has a valid address and things like that to make sure the transaction should go through. And then these miners perform something called proof of work, which I'll talk about in a moment. The proof of work is really a mathematical riddle or equation that they have to solve. And then once someone has solved that, they are given a reward. They're financially incentivized to work on this. That block is then added to the blockchain. The network is updated and the transaction is complete. I think that'll make a little more sense as I talk about what some of these different components are. Okay, so blockchain mining is a metaphor for the computational work that nodes in the network undertake in hopes of earning these new tokens. Okay, so in reality, miners are essentially getting paid for their work as auditors. They're auditing these transactions, and they are doing the work and verifying the legitimacy of these Bitcoin transactions. So, so what do they do to validate the data in the block, right? So these blocks have to be in order. They're in sequence. Is this block, did it precede a block, and has it got a successor and a predecessor? Does the transaction owner own the token or currency that they're offering? And once the block's contents are validated, then the miners begin this concept called proof of work. Okay, so proof of work, okay? Need to introduce this term called nonce, right? So nonce, find a nonce. Nonce is a random number used once, a number used once, nonce. It's kind of a cryptocurrency name, okay? This is a little bit complicated, but I'm going to show you a nice example to make it all clear, I believe. So find a nonce that when added to the block, the incoming block, the result, which is the hash digest, result in n zeros to the beginning of the hash, okay? So n is a variable number. So n is the security level and is determined by the blockchain, right? So the higher the n, the more difficult the mining operation, and therefore the more secure it is, okay? The higher the n, the more work is required, because you'll see it has to guess what number is going to make my digest have n zeros at the beginning of it. And the security level is automatically adjusted by the blockchain such that a new block is added every 10 minutes globally. So there's these computers out there just crunching and crunching and crunching and crunching away at these numbers. Okay, so I think when I heard that for the first time, I thought that's a little bit complicated, but I've got just a fantastic demonstration of that I'm going to share with you now. Do you see a screen that says SHA-256 hash? Anyone? Luis? So can anyone help me out here? Do you guys see this? What are you guys looking at now?
We're looking the website.
It says
blockchain demo. Yeah, SHA-256.
Okay. All right. So this is something I recorded. So thank you for that. And who is that, by the way?
It's Adam.
Okay, Adam. Give me a thumbs up if you hear my audio on here as well, okay? Not 256 hash, but now let's see it in action.
Yep.
Before I do that, though, I'd like to give a shout out to Anders Brownsworth for his permission to use his demo. Now, the input block here labeled data is blank, right? And even blank gives us a 256 hash, which can be seen starting here with E3B0. If I add, I look forward to summer, you could see that it changes the hash quite dramatically. In fact, every single letter or space or word or character, symbol will change this hash quite dramatically. Okay, now let's look at block 1. Okay, block 1, here we show it in red, right? I am looking for summer. It doesn't like this hash, right? What it's looking for here to be acceptable into the blockchain is to have find a nonce that creates 4 zeros here in the hash. So when I hit the mine button, it's going to start at 0 and continue on reading numbers into the algorithm until we get 4 zeros here. So, and this is what the miners do and get paid for, because this takes a lot of electricity to do this. Here we're doing it only with the 4 zeros, but it could be much more than that. So when I hit the mine, we chug along. And then alas, here we go. With a nonce of 57,959, we end up with 4 zeros in the hash. So this block here is now kind of ready to be added to the block relative to the mining operation. Okay, so when we look at the actual blockchain demo here, the actual blockchains, okay, I'm back to block 1. I don't have a nonce in here yet, so let's get one. Now this one goes green because I've got a hash code that works. You can see the previous hash here is all zeros. Why? Because this is block 1. This is one of the things that the miners look at to make sure this all makes sense. The second block has its own data, but I also like the fall. It is not connected to block 1. There's no nonce. The previous hash is correct, but this hash is incorrect. So let's mine it to make the hash start with leading 4 zeros. I hit mine. Now this has the leading 4 zeros. The previous hash starts with C076C6, which is correct here, with a nonce of only 2136. And as we go down the line here, that continues that trend. You can keep winter, block number 3. And you can see now that it correctly looks at the previous hash here, the 66B8. Its own hash has got the leading, actually made it all the way to 5 zeros here, and so on and so forth. So each one of these blockchains now is reinforcing the data in the others. So if I come back here and I want to change this blockchain, all the blocks preceding it, succeeding it rather, will identify this as fraudulent activity. So that's the basic concept behind how blockchain uses a democratic process to kind of police and monitor the data in the blockchain.
Professor Ian Mitchell?
Yes?
You have 5 minutes left.
Good. I should be right on track. Okay. So let's see here. So that gives you hopefully an idea of how proof of work works. Because I know it's a kind of it's a new concept for many people. As we add, you can see here they're adding different transactions. When you have more than one, this is kind of what this starts to appear like, with different transactions all within a given block. As I said, a block can be up to 1 megabyte. So as we add tokens, the chain of the data evolve. Here's what the contents, the format of a block really looks like. So that gives you some sense. There's a lot of overhead and things like that that have to go into there so that the computers could figure out what you're trying to say to them. Okay, so now proof of work, POW, is not without its critics, right? Keep in mind that blockchain has only been around for, I forget the exact number, maybe in 99 or something like that, but in a relatively, it's a relatively new technology. Blockchain preceded Bitcoin, by the way. And I just want to say that Bitcoin is not blockchain. Bitcoin is just one application that runs on top of a blockchain, but it happens to be the most popular one because people, invest in it and have made a lot of money. But it's not without its critics. What's the problem? Okay, so for example, miners across the globe, they are duplicating efforts, right? When they duplicate efforts, it's resulting in an excess energy usage. So due to the competition for the rewards now, what happens is these miners band together and they create these mining pools, okay? And that's really counter to the whole goal of blockchain, was a decentralized web. And so it's kind of fighting against itself. The transactions are immutable. What does immutable mean? Again, that's kind of a term that's kind of a crypto term. Immutable means it can't be changed, right? Now, since immutable transactions can't be changed, that the entire history of the block needs to be reviewed and verified. So it's very inefficient. You're not just looking at the summary. Every time you're going back to the beginning of the block. So that's very inefficient, people would say. But the biggest criticism, and even I've heard Elon Musk, who's a big Bitcoin advocate, he says he says that the energy consumption is a big deal, big problem, right? So the energy consumption by Bitcoin alone is 150 terawatt hours of electricity annually. That's more than the entire country of Argentina, to put it into some type of perspective, right? Which is like 45 million people. So, another problem, it works on this thing called the consensus. So if 51% of the miners agree on a transaction, it gets added and is legit, right? And so that doesn't necessarily mean it's legit, okay? So little sidebar, I always like to give a little history to our students. Ask your students if they know Tolstoy, right? Tolstoy is this famous Russian writer and author of War and Peace. So what is the alternative to proof of work, right? They're working on this as we speak, right? The thing that's the alternative is called proof of stake, right? Now, what proof of stake does, rather than have all the nodes validate the block and have all this redundant stuff, proof of stake quasi-randomly chooses one node to validate the transaction. So you've got all these nodes out here, 1, 2, 3, 4. I'm going to click it 5 times. It will choose one of these nodes randomly, right? And how do you choose a they call them validators, by the way. So how do you choose a validator? So validators need to have made deposits in the chain in order to increase the probability of getting chosen as a validator. And they are paid in order to validate these transactions. So other factors, such as how long have their Bitcoin been in the blockchain, are also being investigated. So I may have a small investment in there, but if I wait long enough, I'll eventually get called to have a job, so to speak, to investigate a blockchain. So of course, proof of stake uses different terminology. Instead of miners, they're called validators. Instead of mining, they're called minting new blocks. And so those are the types of things you have to adjust to. So validators are only chosen to validate transactions that pay less than their investment in the blockchain. right? So this helps create trust, right? Because validators have a vested interest in the blockchain and would not want to devalue that blockchain by cheating it, right? So it's kind of like you don't, steal from your own family. I heard a comment to support point of stake. It would be like stealing from your own store, right? I mean, you're actually hurting yourself. But people say, well, what about the lone wolf, right? Who is is not interested in making money, but they're interested in causing havoc, right? Well, to control some of these markets, they would have to have an astronomical investment, and it would hurt them financially more than it would hurt anyone else. So this is still being developed by Ethereum, one of the blockchain developers, and being rolled out as we speak. So I know I'll keep my time short here. This is in the slides. I won't cover every part of it, but it's a quick review of the pros and cons of proof of work versus proof of stake. Sorry, I'll get that out of your way. And then in conclusion, I'm going to just share you my opinion, which when it's your opinion, you can't be wrong because it's what I think, right? So what's next, right? So some of the features in blockchain, in my opinion, are orthogonal. They're opposite to an ideal social media experience. So for example, immutable. If something's immutable, I can't delete it. So who doesn't regret something they did on social media? Putting a picture up, a bad or a comment, when you're maybe 10, 20 years ago. So having immutable social media is not necessarily a good thing. So part of the appeal of blockchain is the ability to be anonymous, right? And this is not anonymous for the most part. So what's next? I foresee blockchain becoming an instrument in a variety of horizontal applications for business. And I show some examples on the next slide. The megaverse, on the other hand, will really dominate social media. So I see there being kind of two tracks for the World Wide Web, one for business and one for social media, and they're both of equal importance, of course. Here's some of the what some of the experts say are the top 10 usage cases for blockchain. I actually kind of like the supply chain management one because if I'm Boeing and I'm building a plane, where did all these parts come from? I don't know. Are these screws, legitimate, or are they going to be the screw that makes the whole plane go down? So blockchain would be a great way to validate the history and origin of all these different parts. So.